Hi, I'm Ferenc Balint-Benczedi. I'm from the Institute of Artificial Intelligence from the University of Bremen. Basically, I do research in robotic perception, and the work I presented was joint work with my supervisor, Michael Bates, and it's called RoboSherlock. It's a general perception framework for household robotics. The idea behind it is that objects in a human environment basically possess all kinds of various visual cues that are recognized by very different algorithms, and in order to make a robot capable of working in a human environment, you need a perception framework that is able to recognize everything. So objects can be found in drawers and found in refrigerators, they can be in cluttered scenes, or they can be shiny, translucent, and the way we approach this is that we imagine perception to be a question answering system, where you basically ask a question from the robot, which would be detect a handle, or detect a pancake on a pancake maker, or you would say detect me this object in the fridge, or even more abstract questions where you say detect all the objects that are perishable in my environment, or detect all the objects that can hold a certain amount of liquid in them. And the robot needs to be able to answer these questions capably. The challenges here are twofold. One of them, which I already mentioned, was that objects are basically have a lot of characteristics, and the other one is that currently they are treated on an algorithmic level, where you have one algorithm dealing with SIFT key points are extracted, and then the other algorithms basically do model fitting. And in order to have a robot that can recognize everything, you need a perception framework that can enable this. So to this end, we introduced RoboSherlock, and RoboSherlock is based on unstructured information management, and which was successfully used by IBM in their Watson system. So we adapted this to basically work on perceptual data, and we introduce knowledge processing in perception, and through this we are trying to scale perception towards real-world scenarios.